Hi, my name is Nancy. This is the final project presentation for CS90 Cloud Computing, and today I would like to present about Apache Flume. I guess many of you don't know what Flume is. Here is the definition of Flume on Apache website. To say it simply, Flume is a distributed service for moving large amounts of data soon after the data is produced. The common use case is to aggregate the log files to the Hadoop distributed file system. Simple architecture of Flume is shown as the figure here. There are three main components: source, channel, and sink. All components are wired together in chains to form a data flow. Source collects data from external sources, such as web server. The data will be stored in channel until it's consumed by sink. Then sink sends data to a centralized persistent store such as HDFS. Currently, there are two versions of Flume available, and I use 1.4 version on CDS4. In this project, I would like to focus on Flume use case, how to integrate Flume with the data analysis in manufacturing management. So, my challenge is that there are so many machines used in the production lines, as you know, and when a process of one machine finishes, the machine will produce one log file. In one day, there will be a big amount of log files stored in the server. Our goal is to analyze this log data to achieve the quality control and also to improve the production management. First of all, we need to collect the log data from all machines and write it to the HDFS, then pass it through the analysis process. Since I want to collect a large amount of log data, here is the common multi-agent flow that I expected to use. But to make you understand the basic concept of Flume and its use case, I would like to show you a simple standalone mode as an example. But you also can find more information about the complicated configuration of the Apache Flume on their website also. Here is my example. I will create two virtual machines and make them behave like machines sending log data to Flume agent. And I will have another host server for running Flume master. On my host server, I have CDS 4.3 with Java 6 installed. You can find the Flume installation guide from this URL also, and I will assume that we finished the installation process already. And next, I will create two log generation Java application for machine 1 and machine 2. Then I will show you how to configure the Flume agent, how to start the service, and finally we will verify that whether the log data is correctly written on the HDFS cluster or not. Here is the preparation process. I created a simple socket Java program to send the log data with timestamp to the Flume agent on the specific port. And here I specify 11111, the port. Yes, and we just specify the IP address here as the host, and we apply the port. And then after we finish created the Java application program, we export it as an executable jar and move it to the virtual machines. And on the host server, here is the most important part. To set the Flume agent, we need to configure the components in the Flume. First, name the agent and its components. I named my agent as HDFS agent, and I will call my source as log collect, and also my channel as memory channel, and my sink as HDFS write. After that, we have to define the source properties. In this case, the type of the source is netcat one. Depends on the Java application I created. And the source is binding to the host server IP address and is listening on the port 11111. And the source will use the channel name memory channel. Similarly, configure the sync property as shown here. The type of sync is set to HDFS. For this example, text format output will be stored in the defined HDFS part over here. The sync will use the memory channel also. Finally, I configure the memory channel to store data in memory with maximum 1000 events. Before starting the Flume agent service, you have to make sure that you have set Flume home in bash profile already. I save the configuration file as flume.conf. And as I mentioned before, my agent name is HDFS agent, and I just put it in the command here, and we can start the Flume agent directly using the command shown here. After the Flume agent is up, you should see some messages say the source, channel, and sync are starting, and then we can go back to the virtual machines and run the Java application that we created. And then I set the machine 1 to create the log data every 5 seconds and the machine 2 to create the log data every 10 seconds. So the time log data is sent from the machine to Flume agent, a directory on the Hadoop cluster will be created automatically. Finally, on the HDFS, we could get the result like shown here on the slide. You can see that we got the log for machine 1 every 5 seconds at events. Also the log for machine 2. From the example I have introduced, I hope you could get the basic concept of the standalone Flume agent. For the next steps, after we could get the log data stored in the HDFS, we can apply the analytical process to analyze and visualize the big data we got. Also, we can use the result to improve the throughput of the system, also to predict the future events and trends. Thank you very much for watching my video.